All right, let's talk about something we hear all the time, the Internet of Things, or IoT. You know, it's one of those buzzwords that gets thrown around a lot. But today, we're going to peel back the curtain. We're going to deconstruct it and figure out how this whole connected world of ours actually works. I mean, really think about it for a second. That fitness tracker on your wrist, how does it just know how to talk to your phone? Or what about a sensor buried in a farmer's field that tells an irrigation system, hey, it's time to turn on? It kind of feels like magic, right? Well, I promise you it's not. There's a really clear logic behind it all, and that's exactly what we're going to map out together. So let's get into it. And right off the bat, you've got to understand the sheer scale of this. We're not just talking about a few cool gadgets here and there. Nope. We're talking about a massive and mostly invisible ecosystem. All of these devices are constantly sensing, communicating, and acting. It's like we're living inside this giant invisible network that's growing bigger literally every single second. And to really get a handle on this huge ecosystem, you can't just focus on the individual devices. You have to look at the whole system. But here's the good news. It's not as complicated as it sounds. It's all built from a few simple, fundamental components. Think of them like Lego bricks. So, you ready? Let's dive in and take a look at our very first building block.
Okay, section 1, the things that sense. So first up, let's talk about the things themselves. This is the T in IoT. We're talking about the physical hardware, the stuff you can actually see and touch. You can think of them as the frontline soldiers of the IoT world, out there gathering intelligence from everything around them.
And seriously, the range of these things is just staggering. I mean, it's everything from the smartwatch you're maybe wearing right now to the smart thermostat on your wall. But it's also those massive industrial sensors you'd find on a factory floor, or even the car you drive. All of them, in their own way, are just constantly collecting data about the world. So, what's the secret sauce? What's the thing that turns a regular old device into a smart IoT device? Well, it's one word: sensors. They basically give these objects digital senses. It lets them perceive the physical world in a way they just couldn't before. And what's so cool here is how specific these senses are. You know, an accelerometer, it feels movement and vibration. That's exactly how your phone knows when to rotate the screen. A GPS sensor, well, it knows its precise location on the planet. Temperature sensors feel heat and cold. Each one is a specialist, designed to capture just one specific little piece of information from the world and turn it into data. Okay, so our things are out there, sensing the world and collecting all this data. Great, but now what? I mean, that data is totally useless if it's just stuck on the device, right? It needs to go somewhere. It needs a way to talk. And that brings us to our second building block: connectivity. Now, when you're trying to get these devices to talk, there's this one huge fundamental trade-off that engineers always have to deal with: speed versus power. Just think about it this way. Wi-Fi is like a Ferrari. It's super fast, but man, it guzzles gas. Perfect for your laptop when it's plugged into the wall. But what about a tiny little sensor out in a field that's running on a coin battery? It doesn't need a Ferrari. It needs a scooter, something that's maybe a bit slower, but can run for ages on just a sip of power. So for short-range communication, you've got some options you probably already know. Wi-Fi's the powerhouse, right? Great for smart homes where everything's plugged in. Then there's Bluetooth. That's the king of low-power personal stuff. You know, connecting your headphones or your smartwatch. And then you've got these other cool ones like Zigbee. It's designed for a whole swarm of simple devices, like a house full of smart lights that only need to send tiny little messages while barely using any battery. But okay, what if your devices are spread out all over a city or across a huge farm? That's where the long-range players come in. You've got these things called LPWANs. LoRaWAN is a big one, and they are incredible. We're talking extremely low power, but they can blast a signal up to 15 kilometers away. It's wild. And then, of course, you've got cellular, your good old 4G and 5G. Yeah, they use more power, but you get that massive, reliable coverage pretty much everywhere. Perfect for something like a connected car that's always on the move. So all of these technologies we just mentioned, Wi-Fi, LoRaWAN, cellular, they're all what we call network protocols. And the absolute easiest way to think about this is the network protocol is the highway. It's the road the data travels on to get from point A to point B. Simple enough, right? But just having a highway isn't the whole story. The cars driving on that highway all need to speak the same language, or at least follow the same rules of the road. And that's the data protocol. It's basically the set of rules for how the actual message gets formatted. In the IoT world, a really common one is called MQTT. It's awesome because it's super lightweight and efficient, perfect for sending tiny little packets of sensor data without wasting any precious power or bandwidth. All right,
Let's take a quick step back. So we have our things that can sense the world around them, and we have the connections that let them talk to each other. So what's missing? Well, we need our third and final building block, the blueprint. We need a logical design, a plan that organizes everything, so it's not just a bunch of devices shouting into the void, but a real, coherent system.
And this is a really key point. When you imagine billions of devices all talking at once, it sounds like total chaos, right? But it's not. It's actually the opposite. Every single successful IoT system you'll ever encounter is built on an organized, logical, and often surprisingly simple plan.
And this right here, this is that plan in a nutshell. It's a simple 4-step journey for every piece of data. Step 1, the device senses something and collects the data. Step 2, the communication layer transmits that data securely over a network. Step 3, powerful services, usually up in the cloud, crunch the numbers, process it, analyze it. And finally, Step 4, the application presents that information back to you in a way you can actually use, like a chart on your phone or a dashboard on your computer.
Now, inside that blueprint, devices have a couple of main ways they can chat. The first one you already know, request-response. It's a direct conversation. You type a web address, your computer asks the server for the page, and the server replies. Simple. But for IoT, there's another model that's often way more efficient. It's called publish-subscribe. Think of it like a newsletter. A sensor doesn't wait to be asked. It just publishes its temperature reading to a central hub. And then, any app that has subscribed to that sensor automatically gets the new data, no asking required. It's so efficient for this kind of work.
Okay, so we've taken this whole big idea of the Internet of Things and we've broken it down into our 3 main building blocks: the things, the connections, and the blueprint. We've deconstructed it. Now, let's put it all back together and talk about why any of this actually matters.
Here's the most crucial takeaway. The Internet of Things is not magic, it's engineering. It's about intelligently combining these simple building blocks. You take a sensor that can feel the world, you add a network that lets it talk, and you give it a blueprint that lets it think. And when you combine those things, you create these incredible systems that are so much more powerful than any one of their parts.
And this isn't some far-off future thing. The impact is happening right now. This same basic blueprint is what makes remote patient monitoring possible in healthcare, literally saving lives. It's what allows for precision farming, which saves incredible amounts of water and helps us grow more food. It's how our supply chains get so efficient with real-time tracking. It's how we build smart grids that cut down on energy waste. This isn't just theory, it is actively reshaping our world as we speak.
So there you have it. We've deconstructed the Internet of Things. We've looked at the building blocks, the logic, the blueprint. We get the how now. So the real question, the big question, is what's next? Now that we understand how these powerful tools are built, what kind of world are we going to build with them? That's something to think about. Thanks so much for tuning in.